Good morning, sir. Mohan Raj, sir, are you there?
Hello, good morning. Yes, I'm there.
Good morning, sir. Could you please check your audio and screen sharing, sir?
Yeah, I'll do it. Is that my screen visible?
Yes, sir.
Okay, thanks. So let me know when I should start. So I'll
Uh,
stop sharing now.
okay, sir. We will start the session by 10:05, sir. Let the participants be count to increase. We will just start.
Yeah, yeah, okay. Thanks.
Uh,
Welcome everyone. It's the last and final day in this STTP series on machine learning. So this session topic is on some of the concept in machine learning, which is going to be presented by the speaker, Dr. Mohan Raj Venkatachalam sir. I thank all the participants, especially doctorates and professors from various prestigious institutions for making your presence in this session. And also, I want to thank our college management and our CEO, Sri Sai Prakash Leomuddu sir, for arranging the series. And also, I want to thank AICTE for sponsoring the series. I thank our conversant principal, Dr. K. Parnikumar sir, event coordinator, Dr. B. Sridevi ma'am, HOD, Department of CSE, event co-coordinators, Mr. Jaychandran sir and Mrs. Rajalakshmi ma'am for making your presence in the session. So without any further ado, we will turn over our time to our speaker of the session, Dr. Mohan Raj Venkatachalam sir. Dr. Mohan Raj Venkatachalam sir is a data scientist in Renault Nissan Technology, Chennai. His areas of interest are computer vision, deep learning, and so on. He holds his PhD in the field of computer vision and deep learning from MIT Anna University, Chennai. And also, he has published nearly 7 plus journals and books. We are extremely happy to have you, sir. I request our session speaker, Dr. Mohan Raj Venkatachalam, sir, to take over the session. Please, sir.
Thank you. So very good morning, everyone. Okay. I'm going to take over the sessions for two session, the continuous two sessions. The first sessions, what I'm going to do, like some of the business use case which I work in the current industry as well as my previous industry. And then I'm going to talk about in the next sessions transfer learning techniques using CNN, and then some of the deep learning architectures, the pre-trained models, and then how we can use a pre-trained model for the image classifications as well as for the object detections. Okay, so there will be an hands-on one in the second session. The first sessions, which I'm going to talk about some of the industrial business use case with the real-time demonstrations, and I'll also try to explain what are the pipeline needs to be built, especially with respect to ML and DL, and what are the various methods or what are the various metrics to measure any of these business use case. Okay, so quickly I'll have a glance on this before I go no detail of what is machine learning and deep learning, which I want to talk about. What was the traditional approaches? Okay, in this case, if you look at here, my screen and voice is audible, right? Can someone confirm? Uh, j- is that my screen visible, everyone?
Yes,
Hello?
sir.
Okay, okay, thank you.
हाँ
Yeah, thank you.
हाँ बोला ना तुम्हारा
Guys, please go on mute. Some are not on
अपन
mute.
एसी है नॉन एसी है पहले बताओ अगर टमाटर लेके जा रहे तो ठंडा नहीं चाहिए हाँ?
I request
नहीं
participants
वो
to
तो
mute
है
themselves. Fine. Thank you.
So here, so before I go into ML approaches, so what was the traditional approaches? For example, here, the intention is to perform a human activity recognition. So basically, we have a four different kind of activity: person walking and running and biking and playing and some golfing activity. Okay. So the traditional approaches, what happens basically, where we try to get the rule or the speed. Okay, the rule as the speed, and then we try to categorize what activity it belongs to. So what happens, machine will give you the output variable or what human activity it is. So so basically we have to give two things. One is the input, which is a data. In this case, the image is the data, and the rule is the speed. Okay, so the traditional approach is where the user has to give all these rules are the pattern, and then the machine will try to classify what action it belongs to. Okay, so the problem here is that with respect to traditional approaches, assume that you have 1,000 classes, okay, or 10,000 classes. So assume that the number of instructions or the control statements which you are going to have in the script will be going to be very high based on the number of activity. And one more thing is that where in the case of where the last activity where the person is playing and golfing, so where we will not be able to get the speed at all or the rule at all. So what happens, it is basically an application data dependent. So we cannot solve all kind of human activity business use case with respect to the traditional approaches. Okay. With respect to machine learning approaches, if you look at here in the machine learning approaches, we are giving the input and output variable. So in this case, input is a image and output is a label, which means what category it belongs to. What happens, we try to provide a n number of such sample data for each of these activity, with the person is walking and person is running. And these binary patterns or rules are features vector, where the machine is trying to extract all these unique feature vector. So, and one more thing is that the advantage here is that where we'll be able to extract all these feature for the all kind of human activity. But with respect to the traditional approaches, if you look at in the traditional approaches, where there are some of the human activity where we'll not be able to extract the rule or the speed at all. One quick simple example which I want to show here. Consider an mathematical equations. Okay, so where I have a mathematical equations, uh, y equal to 2x minus 1 or 2x plus 1. Okay, x is the input vector and y is the output value, and mathematical equations, which is a 2x plus 1 is a mathematical equations, which is the rule or the the patterns. Okay, so I'll take a simple example, and then I'll differentiate what is exactly going to happen. So I'm just going to run on the Colab. I have the script in my GitHub. So I'll show you what is my Git repository. So some of the these hands-on I'll be using from my Git repository. So you can find all my Git code. Most of the code will run on the Google Colab. I have created most of the notebook file. So I'll tell you which repository you need to follow. So now for this hands-on demonstration, what I'm going to do, I'm going to have these mathematical equations. Okay, so in this case, the mathematical equations, which is a y equal to 2x minus 1. Okay, so with respect to traditional approaches, rule is the 2x minus 1 is the rule, which is a mathematical equations, and data is the x. Okay, so in this case, x is the data. And so what happens in this case, we can provide the x, where I can give it to these mathematical equations. So in this case, x is the, I have a set of x value. Assume that the x value is minus 1. So you apply it to the 2x minus 1, so it becomes minus 2, and minus 1, so it becomes minus 3. Okay, so now what happens with respect to traditional approaches, you will provide these mathematical equations, and then the machine will try to compute the y value, right? So you give the x and the mathematical equation, machine will compute what will be the value of y. But what is going to happen with respect to machine learning approaches, I don't know what is that mathematical equations or the patterns. So what I'm going to do, I'm going to create this, I'm going to give it to the machines with a set of x and y. So x has the 6 value, for the respective x have given what will be the value of y. Okay, so in this case, what I'm going to do, I'm going to create a simple neural network for this particular business use case. So what happens, now my neural network will try to understand what is the pattern with respect to for the given set of x and y. Okay, so now I have built a single layer neural network, because there is a input dimension is 1, and uh, with the stochastic gradient descent, and then I'm going to have the set of x and y, which I'm going to train it with the simple neural network. So now what happens, once I give the set of x and y, and now these patterns will be, these mathematical equations will be identified by the machines. Now what I'm going to do, I'm going to give some value of x. Okay, So but what we did here, basically we have given the some set of values, some set of value for x and y. So if I give some unknown value of x, my machine will try to predict what is the value of y. Okay. So now what I'm going to do, I'm going to ask machine to predict what is the value for this particularly 10. Okay. So now, what happens basically here, by providing this set of data, machine is trying to identify what is the pattern. So if I give the x value is -1, here the value is y value is -3. So similarly, by providing n number of such a sample input and output variable, the machine will try to identify what is the pattern. You assume that the pattern is a 2x -1. Okay. So what will be the value of y in such cases? 10 into 2, 20 -1. So it becomes 19. But usually with respect to deep learning or neural networks, we'll get an approximate value. So where here it says that 89.9. So what happens, the machine, when we are trying to feed all this data, so it tries to play around with the different patterns basically. So it will try to identify 10x plus 10 and 5x plus 5. So when the loss goes very minimal, so those patterns will be taken. Okay. So this is a very simple example which I want to show the difference between basically the traditional approaches and the machine learning approaches. So basically, here you will be given this mathematical, and you will give the x value. Y value will be predicted by the machines. Okay, but with respect to machine learning approaches, what happens? So you give the x and y. These patterns and the rule will be extracted by the machine, and then you provide some unknown data. Machine will try to classify what output category it belongs to. Okay. So now some of the example here might be talked about, like we have set of machine learning classification, or it may be deep learning algorithms, especially for the handwritten digits and the email classifications. Okay. So especially what happens with respect to either it may be machine learning or it may be deep learning, there are two phases are there. One is a training phase and the other one is an testing phase. Okay. So what happens, you just assume that the business use case here, business use case is to classify whether the given handwritten digit is 8 or not. Okay. So this is the business use case. So as I mentioned, the training phase and the testing phase. In the training phase, where we need to collect a n number of sample images with the digits are 8, and other than digits 8 are not 8. So in this case, 8 are labeled as a 1, and the not 8 are labeled as a 0. Okay. So which means class labels in this case, these are 0, not 8, and 8 are 1. Okay. So now what happens, I'm going for the training phase. Okay. So in the training phase, you try to construct certain neural networks or a deep learning architectures, and then you are trying to feed all these training data into the neural network architectures. So there may be n number of layers will be there in the neural networks or deep learning architectures. And then you feed this particular data where it passes across all the layers. And then finally machine tries to classify what category it belongs to. Okay. So in this case, what happens? I'm giving a 8 and the machine is trying to categorize as a 1. For the other than 8 symbols, digits, it is categorizing as a 0. Okay. So now once the model training is done, so what happens, we'll have a certain set of data for the testing, which we called as the inferencing phase. So in the inferencing phase, already you have the trained model. Based on the trained model, you try to predict. Okay. But with respect to deep learning training, where we'll have a two phase, one is a feed forward phase and other one is an backward propagations. Okay. So in the feed forward phase, with the set of weights, a model will try to predict what value of y, and then we calculate the loss, and then we do the backward pass, and we do a weight updation in the each of these layer weight. Okay. So but in case of inferencing phase, there is no learning. But we, based on the training data, already we have the trained model weights, and you feed some test data and the model will try to predict. Okay. So now what happens, for given symbol digit 8, my model has predicted as a probability of 0.9. So we'll put a certain threshold saying that above 0.5 will be 1, less than 0.5 will be a 0. Okay. So which means so the concept here which I want to talk about, any kind of machine learning or a deep learning which you consider, you need to talk about two things. One is the training phase and other one is an inferencing phase. Okay, so in the inferencing phase we try to validate the performance of our trained model. Okay, so now these are the things which I'm not going to talk about more detail. So now I'm going to talk about like what are the steps needs to be followed. For example, I have a certain business use case. Okay, so the business use case here, assume that I wanted to build emotion recognition. First of all, I need to understand what is the requirements of the applications or the use case. Before we start developing something, we should have a clear understanding of the problem statements. Okay, so here the problem statement is to identify the emotions of the persons. So first you need to know, list out what are the different types of emotions you need to identify. Okay, so assume that I wanted to build for the 7 different or 5 different emotions, and then you need to collect a different set of sample data for each of these facial emotions. Okay, for a different age group or a different gender, and so all those things you need to know, you have to collect a n number of sample data for all these kind of no emotions. Once you get these data, then you make sure that your data is structured. Okay, so I have a certain business use case here. This particularly this business use case with respect to COVID-19, we need to identify whether the persons everyone are wearing and face mask or not. Okay, so so what I did, actually I collected all this sample data um, with a different age group and different orientations and angle and and different gender. So close to I have a 690 samples for the person wearing and face mask and person without wearing and face mask. Okay, so I have collected all this data and then I have structured this data. Okay, so structured in the sense we have the class labels like 1.jpg or 2.jpg. So we know which images belongs to person with mask and which images belongs to without face mask. Okay, so this is what we call this structured data. So we have these class labeling informations for each images. Okay, so now especially with respect to machine learning, I have mentioned it is not a rule based approaches, it is a data driven approaches where we need to feed a n number of sample data. Okay, so now once we have this basically the collected the set of data, you need to split the data into training and the testing. Okay, the reason is that basically we need to test the machine learning or a deep learning model on the different set of data. So the same data should not be used for the testing and the training. Okay, so some partial amount of data has to be taken for the testing. Okay, so in this case we should use a more number of 1 second. So in this case, so we are considering 90% of the data. Assume that I have a 5,000 sample images, which I have collected for a different facial emotion. 10% in the sense 500 samples data, which I'm keeping it for the testing. Okay, so those data will not use it for the training at all, so that we can validate how my model is performing on the unknown data, which is on the testing data. So now these are the different ratio where we use it for the training and the testing. Okay, so either you can use the 10% or 20% for the testing, but the thumb rule should be more number of data has to be used for the training than the testing. Okay, so now so basically here and one more thing is that I have talked about the number of facial emotion, right? So assume that I have a 5 different emotions. Okay, so the number of sample data for each emotions or each class should be uniform. For example, if I collect 1,000 sample data for the neutral facial expression, the same number of samples data has to be collected for the happy and other facial emotions. Okay, For example, if you collect, for example, I'm collecting a happy facial emotion with the 2000 sample data. Okay. For the other expressions where I'm collecting 500 sample data, but what happens, the machine will understand on the happy emotions. It will have a more understanding on the happy emotions than the other things. So in that case, model will leads to an overfitting of the cases basically. So to avoid such things, basically you have to collect the number of sample data should be uniform in all cases. So now, what happens once we divide our training data and the testing data? So we have to convert the raw data into one vector representations. Okay, so it may be n-dimensional vector representations. Either you can go for an handcrafted features like computer vision features, like texture features, or it may be key point features, or either you can use for a statistical features, or you can go for a deep learning features. Okay, so once you extract this n-dimensional feature vector, because directly we cannot feed the raw data into the either machine learning or a deep learning classifier, because raw data which is a no, it may change with respect to several changes like illuminations or the orientations or the occlusions. So we convert into one vector representation, and then we train the either it may be neural networks, or you can use a machine learning classifier. Okay, so once you train your model, then you have to validate with the test data. Okay, so you feed the test data and try to measure what is the performance of your no, the trained model with the test data. Okay, so now quickly what I'll do, I just wanted to show some of the demonstrations actually. So now I have the trained models already, especially for this scenario. Model is trained. I'm trying to load this trained model and then trying to make a predictions. Okay, so I have already trained model for this face mask detector, which already trained with this no person wearing on face mask and without face mask. Okay, so now with respect to COVID-19, we need to check whether all these employees they wear a face mask or not. Okay, so this is my trained model deep learning architectures which I used it for the face mask detections. Okay, so now I'm going to show you the demonstration with respect to the live stream based on these trained models. I have these trained models. Okay, so so it tries to predict whether the person is wearing a face mask or not. So in this case, if you look at here, it shows that the person is not wearing a face mask. So it will try to categorize basically a person wearing an face mask or not. Okay. So in such cases, with respect to COVID-19, there should be a norms actually by the government. When we go out, we should wear a face mask, right? So, but most of this industry now they have implemented even in our premises. We have started resuming, but employees has to maintain the social distance, and then we wear a face mask, right? So right now everything has been done by the manually. So can we automate all these task by the machines or AI models, which can help us to alert somebody who doesn't follow these rules basically. So see, many of these use cases are possible no, with respect to AI. One of these business use case which I talked about, no, the face mask detections. Coming back to the other business use case which I want to talk about, which I wanted to talk about the emotion recognition, which I have already the trained models. So everything, whatever I'm showing, I'm not showing on the demonstrations for the how the model got trained. Maybe I'll show you with the simpler use cases, which how we can build a no model for the how we can build a model and we can train for the respective use cases. So after these demonstrations, I'm going to show you how to build a model for the respective data set. So this is the business use case. So I have used a CNN model. There is a Kaggle data set which is available for the facial expression recognition. So which on top of it, which I have built a CNN model. This particularly the CNN model try to classify whether it is a person is happy or neutral. So it will try to classify. There are 7 different emotions are there. So based on this trained model, it will try to categorize whether the person is happy or whether the person is sad or not. Okay. So there are different business use case where we can use this. Especially we can use augmented reality based on the expressions, where we can make a kids playing kind of app where there is a emoji which can generate out of it. This is another use case, basically where we can use this particular business use case for counting of people. So this particular business use case we are trying to use to restrict the number of people which they are entering into the particular area. Like assume that with respect to COVID-19, the number of people which they are allowed inside the cafeteria should be limited. Like 100 people are only allowed to enter inside, right? So we should have some kind of AI mechanism, which can AI model, which can capture the IP camera streaming, and then it will start detecting the persons, and also it will try to track the persons, and then it will identify the number of counts which they enter inside and which they exit from the area basically. So it will also compute the orientation. Based on the orientation detection, it will try to say whether the persons are inside or whether they are going entry. So the similar applications can be used in many places. So we are working on some of the business use case. I request everyone please go on mute. Okay. Uh, can you stop recording some of the business related things which I want to demonstrate? The host, if you could stop recording it, it will be better for me.